Hello and welcome to the 6th video of my JetCar project mini-series. This video demonstrates the StreetMaker application. At the end of the first video I explained how I made my first street map from paper templates and spray paint. It was a lot of work and the map suffered when I moved. But I also needed something simpler for initial test and debugging. So I thought about spending a couple of evenings on a drawing application. Something to easily create street maps which can be printed out rather than spray painting it. Of course, the number of evenings increased a lot over time. The result is a StreetMaker. You can also find it in my GitHub repository for the JetCar as binary and with full source code. Here's the GUI of the StreetMaker. There are toolbars left and right with icons for different elements. On the left are street elements and on the right intersections and overlays. Let's start with a new map and defining the size. Then click on a straight street element and drag it over to the map area. Now get a curve and drag that one over. If you move it close to the end, the program will show possible connections and even rotate the current element so that it will fit. They are now connected as a group. When clicking on one of the connectors with a hotkey for size all pressed, you can now resize the curve element in radius and angle. You can also change each street element or intersection via its property page when you right-click on it. There's also a field for the inner radius and the curve angle. Let's set it back to some reasonable values. This disconnected the curve because the reference side was the other end, but it can be fixed by snapping it back to the straight element. Let's now add an off-ramp or exit and an on-ramp or entrance from the intersection side. They obviously don't fit together like this, but we can extend the curved parts to 90 degrees. And then extend both straight parts in a way that they meet. In this case, it was just adding the lane width on each side. Now we can add full intersections. This four-way intersection clicks right to our curved ramps. And this T intersection can go there. I helped with a hotkey rotate left to snap it on the correct side. Now these two intersections cannot be connected with a straight part, but there's an S-shaped element that can be used. Again, with the hotkey for size all, you can drag it over to snap to the other intersection. To delete any element from the group, you will have to first disconnect it via hotkey D. Let's try a different approach. By attaching a straight element to the four-way intersection. To get it closer, we can increase the length in the property page. There is still a big offset in Y direction between the two ends. You can check the property page for this intersection. I zoomed in via mouse wheel to show the blue numbers on the intersection. These correspond to the numbering in the dialog. To stretch the vertical part here, we have to increase the length value for street 0. Now something new showed up. This window displays the deltas in X and Y directions and even the angle differences between the two surfaces, if any. We are 50 off in both directions. So we add 50 to the length here. And we still have a delta of 50 in X direction, and that can easily be fixed by adding 50 to the street length. And now they snap together. Let's add more. This lane expansion starts from a single lane only, but we need to continue from 2. So we increase the left lane count from 0 to 1 and change the center divider to a yellow dashed line. Now it fits perfectly. You can do the same with the lane merging part. And now you have a turnout, which we can turn into a parking spot. Since we are at the overlays, we can simply add different arrows to the street. They will automatically align with the driving direction of the lane placed on. Let's take a step back now and go through the menus. Left, as usual, is a file menu with New, Load, and Save and Print. The page setup allows you to select the paper size and orientation. Print will send the current street map to the printer. Print outlines only allows making test prints without any color to check the margins and printable sizes. Let's load the medium-sized map to have a street map ready. Reconnect all can be used after disconnecting parts but leaving them in place. Clear all gives a blank map. Resize map allows changing the size of the map, normally to enlarge it. In this case, we discard and load again. The next edit item brings up the application settings dialog. Right on top is the unit selector. When changing the selection, all physical dimensions for the street lanes, lines, etc. on the left side will be converted. The current defaults work well for the JetCar, but could be changed for a bigger or smaller version. There's also the default size for new maps, and below all color definitions for drawing and GUI. On the very right side you can find all hotkey assignments. The defaults are assigned for using the left hand for hotkeys, but you can change all assignment. At the bottom there is the root folder for data storage. All maps will be stored in a subfolder under this root folder. Let's close here for now and get back to the menus. There's a View menu with its items. Redraw simply redraws the whole map, which can be useful when artifacts are left on the map after editing. Show Viewpoints doesn't seem to do anything except displaying another icon on the right side, but we will get to that later. Show Page Limits draws lines on top of the map using the orientation and paper sizes minus margins. It also displays column and row numbers as well as some total page numbers. The last two checkboxes enable overlaying numbers of internal indices. Show Item Numbers overlays the index of each street element on the map in red. This is normally related to the order these elements are placed on the map and added to the list of elements. Show Lane Numbers overlays the index of each lane in the lane array of each street element. This might be helpful information for understanding the inner workings or debugging. Let's turn it all off and go to the next menu item. The Process menu sounds like this application does more than just drawing. There's an item, Create Dataset. Let's click on that. Okay, it asks for some confirmation similar to the image segmenter. Let's see. So this app creates virtual images like the car camera would take driving along this map. And on top of it, it creates the perfect code map. And it also performs the augmentation similar to the image segmenter. Looking a bit closer, you can see how it steps slowly through the street. The StreetMaker allows you to abort the dataset generation via the new menu item Abort. It allows you then to step through all the so far generated datasets. You can see that the file names are generated from the different augmentation indices. You can go through them step by step and check the codes in the mask. That should save a lot of work compared to the image segmenter. Let's go back to the application settings dialog and check out the second tab we hadn't looked at. Now this part has a lot in common with the image segmenter. On top there are subfolder definitions and name prefixes. But here on the left there's a whole section for virtual camera geometries and other settings. The defaults here work well for the JetCar, but you might change some for a different camera chip or lens or things like that. And then there is a section for augmentation similar to the one in the image segmenter. You can try the checkboxes. In addition to the parameters, it shows the number of datasets to be created for the training, validation and testing in total. You can change some parameters to see the numbers changing. But there are some new parameters at the bottom to simulate light reflection spots. We will talk about that later. On the right side there is a similar table as in the image segmenter, with the class names, the color and the class code. But there are differences too. Some class codes are -1. If you look at the right column, their use count is 0. This means these classes don't appear at all in the current map and had been automatically excluded. So all used ones are enumerated without them. This means that the training and inference will only have to deal with the number of classes really used in this map. You can force to reuse all previously assigned classes from another map by clicking the corresponding checkbox on the left. Now let's have a look at how the application creates the masks. In the code there are compiler switches to generate debug outputs. One of them generates images in a special subfolder while generating the dataset. Here's one of those images. It shows just the part of the map that is of interest. However, everything is drawn using the class colors instead of the street colors. There's a small white triangle here, pointing to the right. This is the current camera viewpoint, with the camera looking into that direction. From the camera point of view, it is the driving direction, which is reflected in a light green color for this lane. The lane going down from the T intersection shows a darker green color, which is used for the right turn lane. All other lanes are wrong directions. The lines stop or yield text and other symbols have already their enumerations inside the code and can be easily assigned to the class codes. Only the lane codes change depending on the camera viewpoint. Let's click through more of these images. You can see the white triangle moving forward by some step, and at the same time the horizon on the right had been expanded. This is controlled by some of the parameters in the virtual camera section of the settings dialog. Then it suddenly switches sides, steps backwards now on the opposite lane. And then it does the same on the other parts of the intersection. In all these images it's only drawn what's necessary to create the map in that direction. Everything continues with the next street element in the list and so on. If you zip up the resulting dataset and run the training on it, you can unzip the predictions into the pred subfolder and check now the menu items, display, test and pred. In addition to the virtual camera image and the mask, the predicted mask is displayed. You can step through all test sets and check the predictions from the training. For instance, here it turned out that the yield line was dropped completely. Okay, let's check something. The yield line shows up only 3 times in the table. In this specific case, it actually shows up only when seen from one side. So the statistical appearances are low. And there are some other classes with low counts. How can we get more training occurrences? One way is increasing the map size and adding more elements just for the training. Here we have a complete separate street map under the original one. This one has more on and off ramps and thus more yield lines. It also has more errors, specifically the ones that had only few occurrences in the original map. But this training map includes more. Going back to the View menu and checking the Show Viewpoints item reveals a number of additional dots on the lanes. Zooming in, it shows triangles similar to the camera viewpoints in the previous debug images, but here they can be added manually by the user. This gives much more control over the dataset generation. Instead of letting the code automatically step through the scene, we can now define precisely where to generate specific data. To create more datasets, including the yield line, for instance, just add a number of specific viewpoints with a yield line in view. If there's only one viewpoint placed on a lane, the code will now not step through this lane automatically anymore, but use the defined viewpoints only. Clicking on any of these points will bring up the camera view. With this tool you can now make sure that, for instance, no arrow fraction appears in the dataset. That could be ambiguous. That's the end for this video. Thank you for watching. I hope you enjoyed it and got you interested in watching the next one. And feel free to click the like button. Goodbye.